Hi. So first of all, thank you to the organizing committee. My name is Archana Prabhakar. I'm doing an industrial PhD with the University of Paris in France and SNCF, which is the French national railway company. And Martin from Université Vienne is also following some of the work. Today I'm going to be presenting a study that we carried out to find out how a frequent use of transit maps can potentially influence use as representations of the city. So transit maps are basically schematic diagrams that are used to represent the key elements of a mass transit system. They simplify route planning for travel within large cities that have complex mass transit systems. And they also provide a simplified overview of the geographic space. But to achieve all of this, there is a certain degree of topographical distortion that has to be implemented, which then also implies that the transit map with all of its distortions can influence how users select route choices for travel and how they come to represent the city's geographic space in their mind. In 2008, Jane Vertesi asked over 20 Londoners to sketch a drawing of London. And her findings highlight that the sketch maps tended to be heavily structured around the city's transit map. So here we have the tube map that was created by Henry Beck back in the early 1930s. And here we have two sketch maps that were produced by the participants. And we can see that they're structured around some of the key elements that are present in the tube map, notably the northern and central lines, as well as the river Thames. So her study qualitatively showed that schematic transit maps have the potential to influence how residents represent a larger geographic space. And in turn, we decided to take her findings a little further and to empirically replicate them using the Greater Paris region as a case study. So we basically wanted to test if being familiar with the Parisian transit map impacts residents' global representations of the region. So we recruited two groups of people. One that regularly uses the public transit map and hardly uses the public transit system and hardly uses a private vehicle, and another group that usually uses a private vehicle for travel and hardly uses the public transit system. So following Vertesi's findings, we expected that residents who frequently use the public transit system and therefore its transit map travel and plan their routes will produce sketch maps that hold a closer resemblance to the topographically distorted transit map than the more topographically reliable geographic map of the city. And on the other hand, residents who use a private vehicle for their daily travel and who are therefore less familiar with the transit map will produce sketch maps that are unaffected by the distortions present in the transit map. So their sketch maps will be more topographically accurate and close in resemblance to the geographic map of the city. So we recruited 51 public transit users and 48 private transport users who have lived in the Greater Paris region for at least 5 years. They were all aged between 18 and 50 to 55 years. We asked them to produce sketch maps of 15 well-known landmarks, and then we analyzed these sketch maps against the region's transit map and the geographic map. So for that task, they were given this test layout, which contains a single dot, and the single dot is supposed to represent the geographical position of one central landmark in Greater Paris, which is Notre Dame de Paris. And they were also given this sheet of instructions along with the 15 landmarks that they had to plot. They were basically asked to place the different landmarks around the central point of Notre Dame de Paris, and they were told that they can place them in no particular order. They just had to try and plot all 15 landmarks. So here are two examples of sketch maps, just to see what the end result resembled. We had to eliminate 15 sketch maps at this point because they were missing 3 or more landmarks, and we considered that these weren't complete enough to reflect the city on a global or regional level, which meant that we ended up with 41 public transport users and 43 private transport users in the end. So once we had these sketch maps, we scanned them and we passed them through a software called Gardini Map Drawing Analyzer. So this software basically allows us to extract the Euclidean coordinates of the 15 landmarks on the sketch maps. And we did the same thing for the transit map and the geographic map of Greater Paris. And then because we were interested in cognitive distortions on a regional level, we executed a series of bidimensional regressions on R. This is a method that allows us to quantitatively compare 2 sets of spatial configurations. We opted for these 3 measures from these bidimensional regressions. First, there's a scaling bias score, which gives us an indication of how far distances between landmarks are either compressed or expanded. Secondly, we have the rotational bias score, which lets us know whether the angles between landmarks are rotated clockwise or anti-clockwise. And finally, a coefficient of correlation indicates the overall fit between 2 spatial configurations. So we did 3 sets of bidimensional regressions. First of all, between the 2 reference maps, so the transit map and the geographic map, to verify the similarity between the 2. And what we found was that the distance on the transit map are generally expanded compared to the geographic map, and the angles are rotated clockwise. But for the coefficient of correlation, which is insensitive to scale and rotation, we found a very good spatial fit between the 2 maps. We recorded a score of 0.95, which confirms a certain coherence between the 2 maps. Once that was done, we compared each of the participants' sketch maps to either map. But this time we converted the scaling and rotational bias scores to Z-scores to suppress and do away with the metric distortions that are inherent to the transit map. So taking an example from the private transit group, we can see that the distances on the sketch map were compressed in comparison to the transit map, and the angles were rotated clockwise. And for the coefficient of correlation, there was a good spatial fit between the sketch map and the transit map. And then in comparison to the geographic map, we can observe a compression of distances and an anti-clockwise rotation. And once again, quite a good spatial fit between the 2 maps. So this is one of the better sketch maps that were produced during the study. So to analyze these results, we carried out a set of linear mixed effects, mixed effect models on the three measures for each of the maps. So we found a main effect of the reference map, which meant that the interlandmark distances on sketch maps were generally expanded in relationship to the geographic map, but in comparison to the transit map, they were compressed, and we didn't find a difference between public transport users and private transport users, and there wasn't an interaction between the transport category and the reference map. For the rotational bias score, there was a clockwise rotation of landmarks on the sketch maps in comparison to the geographic map. And in comparison to the schematic map, it was the other way around. There was an anti-clockwise rotation. And this time we found an effect of the transport category. So private transport users tended to produce sketch maps that included an anti-clockwise rotation of inter-landmark angles. And for public transport users, it was a clockwise rotation. But this effect doesn't really mean much without the interaction because they're not exactly in comparison to either one of the reference map. So there was distinction, but not in comparison to either of the reference maps. And finally, for the coefficient of correlation, which indicates the overall fit of the sketch maps against either reference map, we found that there was a close spatial fit of the sketch between the sketch maps and the transit maps. And this was for both groups, so there was no distinction between the public transport users who are more familiar with the transit map and the private transport users who were supposed to be less familiar with the transit map. So overall, what we found out, what we observed was that the scaling and rotational bias scores on the sketch maps tended to be situated between both the reference maps, and this is a result that needs to be considered, taking into account that on the test layout that we gave the participants, the geographical position of the central landmark was given, and it wasn't centralized. So in some sort of way, participants are guided towards a geographical map. So it kind of makes sense that their sketch maps also reflect an intermediary position for these two scores. And there was a closer overall resemblance to the transit map for both groups, which was not what we were expecting. So this raises the question of the origin of this effect. Is it due to the familiarity with the transit maps? Were both groups equally familiar with the transit map in order to observe such an effect? Or are there other general cognitive processes at play which lead to systematic regularizations of cognitive maps? So we decided to take it a step further, and we conducted an extension of the study. So these are just the main results that I'll present really rapidly because it gives a closure to the first study. So what we did was, this time we conducted an online study on 3 regions: Greater Paris, London, and Berlin. And there were 2 phases to the study for 10 landmarks. The task was always the same. They just had to place the 10 landmarks on a sketch map, on a test layout. So in the first phase, they responded to 10 landmarks from their own city, their residing city. So they placed the 10 landmarks on either a blank layout, like the one we used in the previous study with the geographical position of the central landmark and no other elements, or a geographic layout where there was the border of the region as well as main rivers, for example, and a schematic layout where the central point was really centralized on the sketch map, on the layout. And then in a second phase, they learned one of the other 2 cities that they didn't know. So there was a short learning phase using either a geographic map or a transit map. And once they had familiarized themselves a little bit with the new city, they realized the same task on one of the 3 layouts. And what the results tell us is that for the known city, when you know a city, when you resided in the city, you tend to produce a sketch map that has a closer spatial fit to the transit map, and not the geographic map. And of course, the effect reduces once you give them a geographic layout with the borders of the region and the key elements such as the rivers in the region. But for the city you learn that you didn't know, but you learn on the spot, there's a better spatial fit with the transit map if you learned from a transit map. But if you learn from a geographic map, there's a better spatial fit with the geographic map. And which tells us that you need to be, which confirms our initial finding that, our initial hypothesis that the familiarity with a transit map distorts residents' representations of geographic spaces. And so what we esteem is that in the first study, the private transport users, as much as the public transport users, were equally familiar with the transit map, either due to having lived in the region for a really long time and being exposed to the transit map on a regular basis, either on the roads or in public spaces. Okay, thank you.
Any questions for Archana?
The last slide you had the study. You said they should place the landmarks on 3 different layouts. So the blank one is blank, the geographic layout, you said it has the corner
Yeah.
of the city, the geographic one. And how does the schematic test layout?
It's basically like the blank layout, but it doesn't have the geographic position of the landmark. It's just centralized, as it appears on the schematic map.
Okay.
Yeah. So they didn't perform the landmark test on all three layouts. They performed it on either one of it.
Oh, okay.
I didn't mention that.
Yeah, I have a question regarding this final conclusion there in blue. So first of all, I think very interesting work, but this final conclusion, I'm wondering, so in this experiment where people learned from the map, maybe they just tried to resemble the point pattern which they had seen shortly before. So,
That's exactly.
and that is a different learning process than, well, getting familiar with the city where you live in and acquiring your cognitive map and digesting this information that you get over time and building the cognitive map over time. And maybe during this process, this regularization is happening. So it's probably also a matter of how you learn. So whether you just see a point pattern that you then resemble, and then I would say it's not a big surprise that people so they're learning from a transit map, better spatial fit with transit map, learning from a geographic map, better spatial fit with geomap. That is probably not a big surprise if they just shortly before they see the corresponding map, that they then reproduce the corresponding points in the pattern. But learning over time and building your cognitive map is probably something else. Did you consider that?
You mean to say that over time there are more regularization processes that take? It's a possibility, but it is not what we have in our study, and that's of course raises a different question altogether.
In some ways, I think this will lead to the previous experiments, because if this kind of process exists, if you choose people living in the region and use only their cars, like the second population that was studied, they should have built this kind of processes, and so reproduce something which is regularized but based on the information they use, so the GPS or topographic information. And instead of that, they have the same mental representation that people who only use network maps. So the problem, I think, is that on one side you can only study in a sort of longitudinal way, and you have the same elements at the end, while you have two different populations who are exposed to different information. So it's quite hard to say that the same process starting from different points lead to the same results. And here, obviously, you learn and you gave back the information you just learned. And on the other side, we found again the same results we had in the first studies. So I'm not sure this kind of longitudinal process could be at the origin of these results, because the two experiments work together in some ways and exclude this possibility in my mind.
So I was wondering, in the first study that you did, the maps that you got from your participants, they were really just point patterns?
Yes.
Did some participants, I don't know, draw major highways or
there was some
parts of the metro network, because this gives you structure, and a point pattern looks very thinned out.
the task was, the instructions were just to plot the points, but there were a few sketch maps where you find the border of Ile-de-France with the Greater Paris region. There was also the La Seine. So those highways, I can't remember. I don't think there were many highways, but the Seine and the border was one that appeared a few times.
But this you did not match in your correlation coefficient?
No, because that was not part of the task and we couldn't use all of it, no, just the points.
So maybe that's a bit of a speculative question, but does the previous literature, or do you have any insight in that either one or the other conceptualization of city is desirable in inhabitants of a city. So is there any, did they mention any downside if the population of a city conceptualizes a city more closely to what the measure map looks like than what it actually is?
If I just take the work of Vertesi, and there's also some work by Kevin Lynch on the imageability of the city. These are works that actually highlight the positive influence of the metro map on increasing the imageability of a city, the memorability of a city. For example, the tube map, they use it as a promotional tactic on T-shirts and things like that to increase the memorability of the city. And I also, in her paper, in Jane Mortis's paper, she also talks about how a company used the metro map to promote the enterprise. So on the downside, I don't think I've read a paper on it. There surely exists some cons, but not as far as I know in the literature.
I have a question that's maybe a little bit on the technical side, so if it's too complicated, feel free to stop me. But I was wondering, in this analysis at the start, where you talked about the expansion or compression of the distances.
Yeah.
I don't quite understand what that means. Like, if the entire map is smaller or larger, that seems a bit weird.
No, so there's a calculation that goes on. I'll not get into all the details, but
Sure.
what happens is, so there were 15 landmarks. I think that gives us 115 possible pairwise comparisons. So the 115 pairwise comparisons are done, and there's a calculation that goes in to integrate them into a score. It's not an average, but there's something a little more complicated, which reflects the scale on a global level of the sketch map.
But what does that mean? Did they draw the entire map very small or very large? Where does the scale come from?
It means that overall the pairwise landmarks are expanded or compressed.
Okay.
The question is,
Just to finish on the question, I've cited two papers. So the bidimensional regression was a method that was proposed and outlined by Tobler in his paper in 1965, and he has a few other papers. And the Friedman and Kohler paper is one that really highlights the method, the calculation that goes into calculating these scores.
Thank you.
The two bias are calculated only for the 15 landmarks they placed, or in comparison to the original? So first we did a comparison just between the two main maps, the real maps, reference maps. And then for the sketch maps, it was always in comparison to one of the two maps. Okay.
Because you can't have a bias just on the sketch map alone if it's not compatible with something else. So the independent variable was either reference map, and the dependent variable was the sketch map.
Could you, are there particular examples of some concrete landmarks where you can say, like, see, this is how it is in reality, this is how it is on the transit map, and this is where people drew it, see what a strange thing they did there.
So at the moment we are trying to get a visualization of the global distortions in the sketch maps by creating an average or visualization of either group of public and transport users in comparison to the geographic map. But that's being done, and we want to present it today, but it's not yet ready. So, but it will be published in the paper that I cited submitted. Yeah.
Okay. Yeah, that's really cool.
I think that'll allow you to visualize on a concrete level the distortion.
Any further questions at this point? No, that's then. Thank you, speaker, again.
Thank you.